So let's continue with solving these exponential equations, though now we're going to look at some slightly more advanced problems. Notice now we have three different exponential expressions that we have to deal with, but the strategy for these remains the same. We still want to rewrite each of these expressions where the base of each of these expressions is the same number. And from there, we'll use exponent properties to simplify, and we'll essentially end up with a scenario where you have 2 to some power is equal to 2 to some other power. And the only way for this to be true is that the exponents are equal to each other. So we'll first rewrite each of these expressions by noticing that 16 is a power of 2. So 16 can be rewritten as 2 to the fourth power. And let's just rewrite everything by plugging this in for both of these expressions. So we have that 2 to the 8x minus 4 multiplied by 2 to the fourth. We'll plug it in parentheses to the 3x minus 5 is equal to 2 to the fourth raised to the 9x plus 2. And now we'll use our exponent properties. We know that when we raise an exponent to an exponent that we're just going to multiply. So we're going to distribute this 4 to this expression here. So I'll rewrite this first one. We have 2 to the 8x minus 4. But now we have 2 to the 4 times by 3x minus 5. And we will just distribute that. But let me just write it out explicitly for this first problem so that we can follow every step exactly. And we'll do the same over here. This 4 will multiply by this exponent here. So we have 2 to the 4 times by 9x plus 2. And like I said, now we will distribute. The 4 will go to both of these terms. And again, over here, the 4 goes to both of these terms. So let's rewrite. We have 2 to the 8x minus 4 times by 2 to the 12x minus 20 equals 2 to the 36x plus 8. And on the left-hand side, we can simplify this using some exponent properties. So let me make a little bit of room. And what we know is that if we have two exponential expressions where the base is the same, let's say we have 2 squared, and we're multiplying these, so 2 squared times 2 cubed, that we're just going to add the exponents here. So this is really just 2 to the 5th. Now, you can make sense of this with whole numbers by just using basic exponent understanding, by looking at it from basic principles. So 2 squared is really just 2 times 2, and 2 to the third power just means take 2 and multiply it 3 times. So that's just 2 times 2 times 2. And you can see that there are, in fact, 5 2's multiplied together. So this property does make sense, and it does extend to variable or even fractional expressions here. So they have the same base. We are multiplying, so we're just going to add these two expressions. So we have 8x plus 12x, that's 20x. And we have minus 4 minus 20, so that's minus 24. And on the right, we're just going to rewrite it. We have 2 to the 36x plus 8. And notice we're in that scenario now where the base is the same. Let me scroll up and remind you. We have the same base. And so we're going to set these two exponents equal to each other. So that's the only way that this equation can be true. Let me just scroll back down. So this 20x minus 24, we're going to set that equal to 36x plus 8. So let's do that over here. We have 20x minus 24, and that's equal to 36x plus 8. Let me just make a little more room here. And let's solve this. So we have an equation where we have variables on either side. This here is equal to that there. And let's first move all the variables to the right side. There are more x's here, so let's do that. We can avoid negative numbers for our x variables. So let's subtract 20 on each side. Yet minus 24 is 16x plus 8. And now to get x by itself, we'll subtract 8. So you get minus 32 is 16x. And lastly, divide everything by 16. And you get that x is negative 2. Now, at this point, you want to check your work. You can either use a calculator or you can plug it in by hand. But basically, you would go up. Anywhere you see an x, you're going to replace that with -2. And you'll see that this is in fact true. So I encourage you, pause the video, try that out on your own just to make sure that that is in fact the correct answer. So we'll assume it's true and move on to the next one.